The ocean is dark and wide. It covers most of our planet. We think we know the seas, their tides, their currents, their familiar shores. But the sea hides secrets. It guards mysteries in its vast, silent depths, far from the light of the sun and the reach of our maps. One of these secrets, a story written in ancient stone, may be a lost land. Scientists now say there may be a tiny continent under the sea, a world that once knew air and sunlight. It sits far below the waves, a place that is not on any map we have drawn before. The discovery feels like the beginning of a profound mystery story, one that challenges our very understanding of the world's surface. Imagine a place of rock and soil, a vast expanse that is fundamentally different from the surrounding seabed. It is not a mere island, born of a single volcano. It is not just a pile of sand and sediment washed from the continents we know. It is a chunk of the Earth's continental crust, a fragment of a much larger landmass that broke away and was lost to the waves millions of years ago. Scientists call such a piece a microcontinent. It is smaller than Australia or Africa, certainly, but it is far more than a big rock. It possesses its own complex layers, its own geological history, a story that began long before it slipped beneath the water. Today, we can only see the endless blue sea that stretches above it, a tranquil surface belying the dramatic history sleeping below. This hidden landmass represents a missing page from our planet's biography. Its existence suggests that the world map has not always looked as it does today, a fact we know but rarely feel so tangibly. Continents drift, they collide, and sometimes pieces of them are left behind, like crumbs from a giant's table. This microcontinent, submerged and forgotten, could have been a bridge for life, a unique ecosystem, or even a feature that shaped ancient ocean currents and climates. Its rediscovery is like finding a forgotten room in a house you thought you knew completely. It forces us to re-examine the entire structure, to ask what other secrets might be hidden just out of sight, beneath the crushing pressure and the profound darkness of the deep ocean. The very thought of such a discovery is humbling. It reminds us that for all our technology, for all our satellites and sensors, our planet still holds profound surprises. So, how did scientists find this hidden land? The discovery was not a single dramatic moment, but a slow, meticulous process of listening to the Earth's whispers. They used an array of sophisticated tools, each providing a different piece of the puzzle. The first clues often come from sound waves. Specialized ships traverse the ocean, sending pulses of sound, or pings, down to the seafloor. These sound waves bounce back, and by measuring the time it takes for the echo to return, scientists can map the ocean bottom's topography. This method, known as sonar mapping, is like seeing with sound. It reveals the shapes of hidden mountains, vast plains, and deep canyons, creating a preliminary sketch of the world below. Scientists also turned their gaze to space, using satellites to detect minute variations in the ocean's surface, subtle gravity-borne bulges that hint at massive structures hidden below. The final crucial step involved getting up close. Once the sonar maps and satellite data identified a promising area, researchers deployed deep-sea robots, or remotely operated vehicles, ROVs. These incredible machines are our hands and eyes in the abyss. Tethered to a ship, they dive to depths no human could survive, equipped with powerful lights, high-definition cameras, and robotic arms. They take stunning photographs of the terrain, and more importantly, collect physical samples. They touch the ancient rocks, drill into the sediment, and bring back pieces of the seafloor for analysis. It was through these three powerful tools, sound, gravity, and touch, that the true nature of this anomalous patch of crust began to emerge. The samples were the key. They showed rock unlike typical oceanic basalt. Most seafloor is young basalt from mid-ocean ridges, but these were granites and gneisses, lighter colored, rich in silica and feldspar, the building blocks of continents. They were also much, much older. This was the moment of revelation, not a strange lump on the seabed, but a piece of a continent, lost and forgotten by time. What would such a land be like if we could drain the ocean and walk upon its surface? Based on the evidence we have gathered, we can begin to paint a picture. It would not be a flat, featureless plain. The maps reveal rugged terrain, mountains, perhaps not Himalaya high, but significant peaks nonetheless. Deep channels scar its surface, channels that look like river valleys, carved over millennia by flowing water. These were not carved by ocean currents. Meandering patterns and tributaries are the unmistakable signature of rivers that flowed under an open sky, carrying sediment from highlands to lowlands, nourishing ancient floodplains. The fossils in the sediment cores tell an even more vivid story. Microscopic shells of foraminifera, tiny single-celled organisms with calcium carbonate shells. The species tell us about water temperature and depth when they lived. Even more exciting, pollen grains, fragments of terrestrial plants, pollen of trees and ferns that only grow on land. Irrefutable proof this region was once a thriving, dry ecosystem. These tiny, resilient grains, preserved for millions of years in the seabed, are whispers from a lost world, telling us of ancient forests and climates long past. This discovery could rewrite textbooks. It challenges and refines our maps. Works in progress, especially with 70% of the world hidden by water. Finding a microcontinent is a major cartographic event, forcing us to redraw boundaries between ocean and continental crust, and suggesting other fragments may be scattered like puzzle pieces. Second, such a land provides a scientific basis for ancient myths. Nearly every culture has stories of great floods and lands that vanished beneath the waves. Plato's Atlantis, sunken cities of folklore. This may not be Atlantis, but it proves entire landmasses can sink beneath the ocean, linking modern science with our fascination for lost worlds. To understand how a continent can become lost at sea, think simply. The surface is a mosaic of tectonic plates, moving as fast as fingernails grow. Over millions of years, they reshape the globe. New seafloor at ridges, mountains at collisions. During continental rifting, fragments can tear away like crumbs. Slivers of buoyant continental crust left adrift in new oceans. Over eons, they may sink under sediment weight, or cool and contract, eventually submerging beneath the waves. Oceanic crust is usually under 200 million years old. Continental crust can be billions. Dating showed rocks hundreds of millions of years older than the surrounding seafloor, the geological smoking gun. This piece of land did not belong there, a relic from a different time and place, preserving Earth's grand, slow dance. I remember, years ago, holding a fossil in my hand, an ammonite, a spiral shell from over 65 million years ago. Holding it, I felt a profound connection to a world I could never see. Time so immense it's hard to comprehend. The discovery of a lost continent evokes that feeling on a grander scale. To stand on a research vessel, knowing a sunlit world once lay thousands of feet below, is deeply moving. Curiosity and wonder drive explorers, from the highest peaks to the deepest trenches. These scientists are on a quest, piecing together a story. Each core is like a fragile, muddy manuscript. Back in the lab, they wash away sediment and analyze microscopic clues, historians deciphering an ancient text. We see land and sea as fixed, but this finding shatters that illusion. The world is in constant flux. Mountains rise, mountains erode, seas advance, seas retreat, entire continents can be submerged. It instills humility about our place on this planet. It is a tale of loss and rediscovery. What is lost is not always gone forever. With patience and ingenuity, we can bring these worlds back into the light with science. Section 6. The data from deep-sea expeditions is filled with astonishing details that bring this lost continent to life. One of the most compelling pieces of evidence is the presence of ancient river channels etched into the bedrock. Using high-resolution sonar, scientists can trace these features for miles, not landslides or current gouges, but sinuous, branching, fluvial patterns. You can almost see water flowing, eroding the land over countless centuries, now preserved 2 miles beneath the waves. A ghost river in a land of ghosts. Another surprise, distinct bands of ancient soil, paleosols, with structures and chemistry that form on land, exposed to air, rain, and life. Within them, traces of charcoal, evidence that fires burned here, sparked by lightning or volcanoes, a dynamic landscape of weather and seasons. Just decades ago, the deep ocean was a blurry realm, less mapped than Mars. Today, our view sharpens each year. Autonomous vehicles survey for weeks, intelligent scouts mapping lost worlds while scientists watch from miles above. And when geologists finally see granite outcrops on the seafloor, or hold a piece of land-formed rock raised from the abyss, there is triumph and wonder. The moment a hypothesis becomes tangible reality. What other landscapes wait for us in the dark? What else is down there waiting to be found? Section 7. This discovery doesn't just change geology, it impacts the history of life. Submerged landmasses could have been crucial bridges for plants and animals, answering puzzles of species found in far-flung places. A well-placed microcontinent could explain how flightless animals or certain plants crossed vast oceans. These isolated lands are natural labs of evolution, the same process behind Madagascar and the Galapagos. A lost continent could host unique species found nowhere else. The fossils might be entirely new branches on the tree of life. The work has just begun. Every core is a lottery ticket, perhaps holding bones of reptiles, mammals, or strange birds from a vanished stage. Here's the cliffhanger. What if we find life forms that challenge our classifications? Products of tens of millions of years of isolation. The search for such fossils is a primary goal now, and the scientific community waits, eager for the next dispatch from the deep. It's, I guess, a reminder of how remarkable our search for knowledge really is. Section 8. While the discovery of a sunken microcontinent is monumental, it opens a flood of new questions, more compelling than the finding itself. What are its exact size and shape? We've mapped fragments and edges, but the full extent remains unknown. Was it a long, thin sliver connecting continents, or a more compact island-like mass? Tracing its complete boundary will take years, connecting dots across thousands of square miles of unexplored seafloor. The final map is yet to be drawn. Another question is its history. How old exactly? When did it break away? How long did it stay above sea level? When and why did it sink? Was the sinking slow and gradual or catastrophic? The most evocative question, did humans, or our ancestors, ever set foot on it? Most microcontinents sank before Homo sapiens, but if parts survived into the last 100,000 years, early mariners might have reached shore. Searching for stone tools, ancient hearths, or middens is a long shot, but it must be asked, did we have a lost ancestral home beneath the waves? These questions will guide the next generation of exploration. New expeditions will be planned with these goals. They'll deploy advanced robots, drilling deeper, collecting pristine samples, and use new imaging to peer beneath sediment. Geologists, paleontologists, oceanographers, archaeologists must collaborate to piece the story together. The discovery was not an end, but a beginning. It has opened a door to a new field of inquiry, and this mystery will captivate us for decades to come. Section 9, a final reflection. Why does this discovery matter so much right now? We live in a time of unprecedented environmental change. We watch as ice sheets melt and sea levels rise, threatening coasts worldwide. A continent that sank long ago is a visceral reminder that sea level change is not just modern, it's fundamental to our restless planet. The Earth is not a passive backdrop. It is a restless, dynamic system. Boundaries between land and sea are not permanent. Changes today are part of a very old, powerful story. Yet this story also gives wonder and hope. In an age that feels fully explored, the planet can still astonish us. There are new worlds to find, not in distant stars, but here, under the blue. This knowledge can reignite our collective curiosity and our passion for exploration. The story of a hidden microcontinent is a tale of immense loss and profound surprise. A lesson in geological time, a force that can build mountains and hide them in the abyss. It is a call to explore, to keep pushing the boundaries of what we know. The ocean remains our last great frontier. Every mission, every sample, every new image can change a line in our world's story, adding detail to its past, present, and future. The sea keeps its secrets well, but not forever. With patience and ingenuity, we're learning to read the signs, deciphering the history of lost lands and the life they once supported. What else is down there waiting to be found?